Hi guys, so this video is really looking at some key content and key areas of knowledge that we want you to take away from this inland water systems unit. And I think this video will really be able to help you with these key understandings. And they're kind of some areas of knowledge, some definitions, some explanations that will help us in the next couple of weeks. So try and use this as a bit of a go-to video. If you're unsure of a definition, please come back and check this. Now these are the key concepts to take away from this video. We've got one at the top there, some sources of inland river systems. I'm not going to touch too much on that, but I'll show you a slide looking at that. And the next dot points are really what we're looking at today, the physical aspects of a river, including the source, tributary, confluence, watershed, the river mouth, an oxbow or billabong, river meander, river erosion, and river deposition, estuaries and deltas. All different physical aspects that you'll take away an understanding of today. Just some key words for you to maybe add to your glossary of terms you could be asked throughout the next couple of weeks. Where a river begins, it's called its source. So wherever the river begins, where it's at the top of the valley, where it usually might be, it's called its source. A small river meeting a larger river is called a tributary. Where two rivers join is called a confluence. Where the river flows into the sea is called the mouth. The area drained by a river is called the drainage basin. The line that separates two drainage basins is called the watershed. So you'll understand those a little bit more by the end of today. These are the sources of water that I mentioned at the start of this video. We've got a few here. Water storages, as we can see up in the left here, that's a dam, irrigation, hydroelectricity, ports and harbours, transport, fish farms and recreation. So just taken away from this slide, we can see that how we use our water is very important. Economies obviously are run on water. Okay, this is a really good diagram that shows different aspects, different physical aspects of a river catchment. So the river catchment, or the drainage basin, is an area of land drained by a river and its tributaries. So we can see the drainage basin here. Now, this is directly related to the watershed. The watershed is an area of high land between two drainage basins. So think of this as your boundary. We can see that it's dotted going up here, all the way up to the water source, and then back around down here. That's your boundary of your drainage basin on either side of this. So we can see here, think of this as a high peak. Anything that hits here will come down into this basin. Anything on the right hand side of this watershed will go to a new drainage basin, a different one, not this one, probably be next to this somewhere. Likewise over on this side. Okay, our source is the beginning of the river. A tributary, a small river or stream that flows into a larger river. So this is our main river, and we can see these black lines representing smaller offroots, smaller rivers. So there's a tributary, a small river or stream that flows into a large river. So where that fork is, that's what we call a tributary. Related to that is the confluence, where two rivers meet. So here we can see the confluence meeting the main river. Again, this black line representing a river itself, coming from a different area of the drainage basin into the main river. The mouth, where a river flows into a lake or sea. Here's just a couple of maps of some catchments around the world. So we've got the Murray-Darling Basin here, Mississippi River catchment in the United States, and the Indus River catchment in Pakistan and northern India. Here are some inputs and outputs into a river catchment, and this is again related to the water cycle which you got introduced to in a previous lesson. I've got 2 inputs and 3 outputs. Our first and probably most important input into a river catchment is the source or headwater. That's obviously going to be rain in the form of precipitation. Again, it's going to be high in the valley where gravity can take its course and take it downhill. A couple of outputs as it's going down the hill. River water soaks into the soil. That water can't be used again. It's obviously going into the soil. Once it gets to the bottom of its system, river water and sediments run into the sea. Again, that's an output. Evaporation is another output. So the heat coming down from the sun, heating both the soil and the water itself from the river, evaporates that water into the sky, which then is related to precipitation and causes rain, and the system continues. This is another good diagram showing floodplain features in the lower section of a river catchment. Now what I want you to take away from this is this term here, an oxbow. It's also called a billabong. Excuse me. Now we can see that it's separate from the main channel, can't we? And you're about to learn why. Just before we do learn that, meander is where a river changes course and does lots of turns. Rivers meander, twist in or loop in, all the way down their course. This happens because the terrain over which they flow is uneven. It may have harder rocks, boulders, uplifted hills or mountains on it. This changes the direction of river flow, pushing the channel around these obstacles in wide loops called meanders. So some really good examples here. So it's where it loops around Now we're looking at river channel erosion and deposition. Now this is an interesting process that might take a little bit to understand. This diagram up here on the left explains it really well. Now we have to understand that as water comes down a river, it has different pressures in different parts of the river. Coming from the top here, the water's coming down in this direction of the arrow. When it hits this corner, it's going to have more pressure on these banks as opposed to this corner here. So where this black line is around the river bank, that's going to be eroded, or there's going to be more erosion there as opposed to this side over here. We're more likely to get what we call deposition. So on the inside of a bend, we have deposition. On the outside of the bend, we have erosion. If we follow the arrows around, we come into a new bend. On the outside of the bend, erosion. So fast flowing water with lots of energy is directed into the outer bank. This erodes that edge. On the inside, where the water's slower and not as much energy, we get deposition of sediment, causing the bank to be higher than on this side. And again, happens on this side. Erosion, fast energy, deposition on the inside. And again, this image shows it again. We have a meander, and that causes erosion on the outside bank, but deposition on the inside bank. Riverbank erosion. Stream is eroded when the flow of water, called the current, undercuts a riverbank, leaving a steep side which eventually slides into the water. And this can carry down and be sediment in the stream. Okay, back to our oxbow lakes. Very related to our meander system. Oxbow lakes are the remains of the original path taken by a river. So this looks very similar to our meander, deposition and erosion image from before. We've got to imagine an oxbow lake was once like this, but due to the massive erosion on the outside of each corner, that over time that stream just becomes one. So we can see that the energy has eroded the outside banks of the two meanders and actually caused the water to come through. Deposition takes place and seals off the old meander, which results in an image like we have here at number 3. Flowing stream, but with an offcut, or an oxbow, or a billabong. So we have to understand that process. Looking at it again, water coming down from number 1 into the meander, energy erodes the outside bend, water flows around, again over time, water erodes the outside bend. Eventually these two narrow necks join up. That's how an oxbow lake or a billabong is formed. Again, that's explaining that. If you'd like to pause and look at that yourself, please feel free. And that's actually explaining the oxbow lake again as well. Just thought I'd put that in there in case different images might be more suitable for people to understand. Again, feel free to pause it and read over that yourself. Okay, river estuaries. An estuary is a place where the river flows into the sea. The mouth of the river broadens to form a wide inlet. Seawater may flow in and out of the inlet depending on the tide. So there's some different examples of estuaries. A delta is related to an estuary, but it's a landform that is created at the mouth of a river where that river flows into an ocean, sea, lake, reservoir, flat, arid area, or another river. Deltas are formed from the deposition of the sediment carried by the rivers as the flow leaves the mouth of the river. Over long periods of time, this deposition builds the characteristic fan or finger-shaped pattern of a delta. So this top image explains this really well. So the delta here, different channels, what we call distributary channels. Okay, so the water's been distributed. That word comes from the word distribute. Distributary channels, where they fan off into different river mouths. The river breaks into several channels called distributaries before it enters the sea, as I just said. Now here's some different types of streams. We have braided streams and separate channels down here. Not going to go into this too much. Now this image is familiar to you guys. We looked at this in class. Now that we've got an understanding of key physical concepts and characteristics of a river, we can again look at this and label a few of those characteristics. An anabranch we didn't talk much about today, but it's a river system that leaves the main flow and comes back and meets it again somewhere else. So this here would be an example of an anabranch. The main channel is obviously the main river system. Tributary, we know that it's a smaller river meeting. Meandering, river meandering, we can see that this is an example. Now I couldn't find an oxbow or a billabong example that really stood out, but I'm sure there's one or two in there. So just revising on what we want to take away from today. Some uses of inland river systems and these physical aspects of a river, including the source, tributary, confluence, which is it's related to the tributary, watershed, which is the boundary of the drainage basin, river mouth, an oxbow or billabong, meandering of a river, river erosion and river deposition, again directly related to an oxbow creation, estuaries and deltas. Please save this video.